All right, let's start. So first of all, thanks for coming. Seriously, I'm thrilled to see y'all. I'm really good with the conversational style. You have questions. If we get completely bogged down in questions, I'll move us on at some point. But I love questions, so hit me with them. As I said before, it's the second time I've given this talk. That doesn't mean that I'm like not prepared, but it also means that I haven't heard all the questions yet. So let's, it helps me to hear from you for sure. So I've been seeing this for a long time. When they approached me, when PASS approached me about speaking again this year, they always want me to do an Excel session, right? And that's what I'm doing later. Good to see you. Have you met Grant?
I have met Grant.
Yeah. I've been seeing some form of this question, this problem, for the better part of 10 years now. And when it came time to pick what my other talk would be, I said, listen, I think the thing that would be most helpful if people show up, right? The most helpful thing I could do for the PASS crowd would be to try, anyway, to explain what you're missing if you're, like most people, if you're locked in a SQL-driven mindset for everything. So that's my goal here today. Quickly about me. So I grew up at Microsoft. I've given more talks probably at this convention center than any other place I've given talks because I used to live across the bridge in Redmond. So straight out of college, I went to Microsoft. I was there long enough and got into those good mid-level manager jobs where you can get to the point where you can get abused by Microsoft's CEO types. I managed to hit the trifecta. I got scolded or abused by all three of them in separate face-to-face meetings. It was fantastic. But probably the number one thing that I took away wisdom-wise from working in the belly of the beast all those years. And by the way, I don't have stick figures for Bill, Satya, and Steve, but I do. This is actually a stick figure that we've custom commissioned to represent Bill Gates standing on Mount Olympus made out of money, bequeathing technology onto the IT crowd and the number crunchers, right? These are 100% custom for us. This is Power Pivot Pro intellectual property. However, we're not using those in this talk. Just wanted you to show that we had them in case we needed them. So when I was there, I worked mostly on Excel. I worked on this first thing called, I was recruited, one of the last things I did, I worked on Power Pivot, which was originally called Project Gemini. And really that morphed into Power BI over time. Even though I was out of Microsoft before the words Power BI existed, I basically worked on the earliest versions of Power BI. Like I was going to say, the thing I learned about software from working on it and seeing how people use it is just how much we let software off the hook, how bad software really. I'm a really fierce and harsh critic of software now. I hate software, right? More than anyone in the room, guarantee it. And yet I'm here to tell you about something that I actually love, and that kind of stands out. So there's a lot of misuse, a lot of things that are designed for purpose X, and they're actually trying to be terrible at purpose X. A lot of things that are designed for purpose X, and people use it for purpose Y. The software world is a bigger mess than we give it credit for, I think. My friend Bill Jelen says there's only two industries in the entire universe that refer to its customers as users: the software industry and the illicit drug industry. There's some truth to that. So then 10 years ago, and with the obligatory in a galaxy far, far away, in a galaxy called Ohio, okay? I saw something about these tools, this new wave of tools, the Power BI wave of tools, which again weren't called Power BI yet. I saw something that told me that the world, I just sort of knew it. at that moment 10 years ago that the world was going to change in very, very, very significant ways. The world of data, the world of analytics, that what Microsoft had come up with was like way better than any of us who'd worked on it, any of us had even dared to hope. And at that moment, I can almost point to like the minute that this happened. At that moment, I bet the rest of my career, from then till now at least, and for the foreseeable future, on this set of tools. So now, I formed a company because I knew that one of the things we needed was a different kind of consulting organization, a different kind of professional services firm to fit the velocity of these tools. The previous wave of tools sort of lent itself to a DNA, just sort of like gave a DNA code that was here's the types of professional services firms that you need to build to deliver these sorts of services. These tools require a different sort of DNA. And literally 10 years ago, I was like, okay, we need to go build that company. Now, tremendous, you've heard the saying, tremendous foresight, terrible depth perception, right? I thought it was going to be like, well, we'll just go do this in 6 months, and the world will catch up, and everything will be great, right? So here we are 10 years later, and we're still early in this transformation. Way early. Super, super, super early. So now, I've moved to Indiana. We've expanded to all of the states pictured. We're not everywhere yet. We've got millions of dollars of revenue. However, even though we're not everywhere yet, I'd like to point out that if this were an election, we would carry the Electoral College. Right? So we just, like we have someone that's thinking about maybe relocating out of Texas, and I'm like, well, okay, maybe, but Texas is 38 votes, anyway. So you might know us because from our book, this book, despite sort of being long in the tooth at this point, is still the #1 selling book on Power BI. So if some of you might have it, some of you might have read it. Okay, so enough about me. Let's talk about public enemy #1. You know what I'm going to say, right? Public enemy #1 for analytics, reporting, BI, all of that is, in fact, in my opinion, our good friend SQL. Right? And I'm not here to pick a fight. Like, first of all, this is even better. I don't know SQL. Right? I get to speak at PASS, and I don't know SQL. I mean, I know what it does, and I know about select statements and where clauses and all that kind of stuff, but I can't write one. Remember, I don't really like software. I've only learned a few things in my life in any great depth. The rest of the time, I've just been mailing it in my entire career. Okay? I've learned Excel really deeply. I've learned the DAX formula language really deeply. Maybe end of list. I've been around these things forever. Conceptually, I understand them. But I'd be a terrible, terrible SQL developer. I'd be a terrible DBA. I mean, I could learn it. But today, I wouldn't be able to do anything with it. Now, the problem with SQL is not that it's bad. The things that it's designed for and the things that it was originally built for, it's amazing at. It's really unmatched at it. I mean, even with all this new wave of semi-structured data lake stuff, what do we see? We keep seeing SQL layers spring up over the top of them, right? So SQL's on to something. There's something really good about SQL. So I'm not here to trash it. I'm just here to sort of tell you that it's that whole adage of when you're a hammer, everything looks like a nail. And it's just adequate enough at analysis that you think that it's okay, and so you stick with it, and you just keep going to that well over and over again, and then things start getting out of hand, But probably even worse than the trouble that you end up in, like the tangled mess you end up in when you're relying on SQL as your analysis layer, is what it distracts you from. It's the things that you don't see. It's the things that you miss. And I'm here, hopefully, this is the goal today, right, is to open your eyes to that thing that you're missing. And those of you who are, sort of like already kind of like on, in my camp with this, hopefully for you, this will help you explain it to other people. Because this, again, is something I've been struggling with. I have friends right now who are going through exactly this process. They are so good at SQL. Incredibly good. I'm in awe of them. And the businesses that they run and the scale that they run at, it's incredible what they have done with SQL. And every time I go to visit them, I'm just like, whoa, like even me, and I always preface it, like even me, I can add value to your company like right now. Look at this, like I can do things that you can't do. And it feels unfair because I'm cheating. I'm not as smart as them, right? That's why one of those titles, the alternate titles was, if I can do this, you should be able to do this. All right, so it's a little bit of a history lesson, and then most of the talk, we're gonna be in Power BI, okay? So everyone, whether they're technical or not, just really basically anybody knows that data has to be stored somewhere. Right? You have to save it, you have to keep it, right? And then we also know that we need to look at it, right? We need some charts, we need visuals, right? So I call this storage and charts. Everyone knows that we need storage and charts. And that's where we started, right? We started with storage. And then it's almost like charts came like a millisecond later after storage, right? And well, of course, SQL is designed for storage. And all of the new things, actually, we could treat SQL, whenever I say SQL, we could treat it as like a token that's a representative of everything that's sort of storage, all storage philosophies. So like, including like Hadoop and things like that, right? So it's really about storage tech whenever I say SQL. And you know, the number one selling product in Microsoft history in the BI space forever, as far as I know, certainly when I worked there, was reporting services. Right? And reporting services doesn't have a brain of its own. And it is like almost like a formatting layer that transforms your SQL query results into HTML or something else, right? It's almost like an XSL transform or something, right? So that means that the brainy stuff, where does that happen? It happens in SQL. This is where we landed. SQL is great at cleaning data, especially like, again, storage technologies have a lot of stuff, a lot of technologies associated with them that are great at cleaning data. For years in SQL, we had SSIS, now we've got things like data factory. We've got all kinds of stuff at the storage layer. And I still think that the storage layer is a great place to do sort of cleaning and reorganizing of data. But we've also, oh man, this is where it gets insidious. SQL has some calculation capabilities, doesn't it? It's got group by, things like that. So you didn't think I knew about group by, did you? Yeah. I know that it exists. So this is the trap that we've fallen into. And by the way, all of the new Linux cool kids, you know what I'm talking about, the ones that like they came out of, they've never worked on any computer other than a Mac, right? No, I would never use anything that came from Microsoft. Everything's on AWS, right? They're on the Silicon Valley show. They only do things like MongoDB and NoSQL. Those are the only things that they've ever touched in their entire lives, and they would never, sink to the level of using any of our type of stuff, right? Even that generation right now is in exactly this same trap, right? They're not any better. And that's one of the things I was testing out at that first developer conference. Was like, there was a lot of youngsters in the room. I'm like, oh, okay, come on, let's throw down. Let's have a little, can you do this? No, none of them. They were just as jaw-dropped as the SQL people. So hey, right? Are there? No, you would never identify yourself anyway. If there was a Linux cool kid in the room, you wouldn't out yourself, would you? Yeah. All right, but that's the thing I want to start that. Can we start that as a demographic, the Linux cool kids? Yeah. All right. So this is the thing that we're missing. The notion of a middle tier, right? And oh boy, middle tier is not something brand new, right? The concept of middle tier, but what OLAP does, and Power BI's brain is very much an OLAP brain. What it does is what we're here to talk about. It's a crucial middle person, not middleman, right? Middle person between the storage layer and the reporting and visualization layer. Okay, so 2 more slides, and then we're jumping into the tech, okay? So here's what we end up with. If we end up with, so every business, we have to take a step back, right, from our individual databases and data stores and all that. Every business person I talk to is constantly saying things to me like, yeah, you know, we need our systems to all talk to each other. And for years, I've been trying to understand what they mean. And I know there's some operational flow stuff that needs to happen, like we need to be able to send some records and some events and some triggers from one system to another and, like, you know, write some information from this system into another system. That's real. But at least half the time what they're really saying is that we need to be able to see across our systems from a business standpoint. That's what they're actually saying at least half the time. They're not actually thinking that they need, you know, that's just the best way they can describe it, is we need them to talk to each other. So you end up with, you know, every SQL store, every storage layer generates its own family of reports. And we tend to say, aha, that's good, we make report, right? Report is good. But it's also absolutely silos of information. And here's another dirty little secret. Some of you might know this. But every report that you build, without even seeing it, I can bet you in advance that no one's looking at it with their eyeballs. Right? First of all, there's a really good chance no one's looking at it at all, even though they say they are. Okay? That's the first dirty truth. But the second dirty truth is whenever they look at it just long enough to press the export to Excel button. Okay? We, the IT community, have denied the business access to the databases because, you know, they would screw things up, right? They have done a complete end run around us and have used the reports to reconstitute databases to do what they actually need to do. Okay? Now, again, without even seeing your reports, if I bet you at even odds over and over and over again that no one was looking at with their eyeballs, I would make money, big money over time. That would be a winning strategy. You want to take me on? I'd love that. That should be my career. That right there. This gives us 2 things. Number one, we're siloed. Each storage layer feels like it's a little happy own little universe. And the question velocity, another term I'm trying to coin here, the question velocity is really low. When the business has a different question, it has to go back ultimately down to the storage layer to be converted into answers, right? And that takes forever. And it's not because anyone's doing a bad job. There's just a million good organizational and human reasons why that takes a very, very, very long time. There's even like an industry metric that adding 1 column to an existing report takes like an average of like 9 business days elapsed, right? Like that's the equivalent of a single check click, right? It should be like 1 mouse click, but it's 9 business days. And again, I don't think it's because anyone's bad. I just think it's because the processes are just sort of dictate this sort of speed. So the left side of this slide, we should say, is not good, right? Because the business needs to be able to ask questions across silos. Absolutely, right? Like one of these silos has got your revenue, another one's got your costs. Okay, right? Like all that matters is your margin. So like right off the bat, you're just kind of like unable to see anything. And this is why people are exporting, right? They're exporting reports from 3 different systems, cobbling them together in the same spreadsheet to come up with some sort of unified end-to-end life cycle answer about the business. So we need to tear those walls down, right? And then the very next thought that occurs is that, oh, so this is where the SQL mindset, the storage mindset continues to reassert itself. It says, all right, well, what we really need is one database to rule them all, right? That's where we've been failing, is we haven't built that one database yet. And this thing never, ever shows up. It's the thing you talk about. It's the future thing. It's always the future thing. And you know what? You wouldn't even want it. If you ever got it, if it ever showed up, it would be fearsome. It would hurt. It'd be incredibly slow. It'd be an incredible failure. And so just give up. Don't keep waiting for the arrival of the all-knowing single data warehouse, right? Just let it go. Now the other good news is that you don't need it. If we build a data model instead, and allow the data model to pull from each of those silos. You never have to integrate those data sources into one database. You never have to teach them to talk to each other. There's just one thing, the data model, that has its own sort of like one-on-one relationships with all these different data sources, and it's the place where they meet. It's the only place where they meet. And from there, you build your reports. But the really good news is on top of that, is that you can't just get one report out of a data model. Once you have a data model, you basically built like all of the reports. The velocity of questions that can be asked and answered. I mean, it's not an exaggeration to say that it's at least 1,000 times faster in real world terms. And we don't often get numbers like that are, unless they're hyperbole, right? But when it's 9 days to add a single column to a single report, there's a lot of low-hanging fruit out there. Okay? Does this make sense? I haven't had any questions or objections yet. Someone give me a question or an objection or something.
I'll give you a question.
Mm-hmm.
You say there's no need for a data warehouse. I'm a little confused by that. Are you saying you think about symbol type?
Yeah.
Facts, dimensions, performance dimensions?
Yeah.
And none of that's necessary.
So what I'm really saying about data,
In the old corporate information factory, which I think we all agree pretty much had,
yeah.
but symbol, no?
Well, okay. So I know Kimball's book, right? It weighs like 30 pounds, you know? I've never read it. Okay? I'll be completely honest about that. Yeah.
You should, bro.
I should? Oh, yeah? That would help? Yeah.
We've paid the price already.
Yeah, have you? All right. Well, the thing is, I haven't been held up by it, by the lack of reading it. Here's my advice. Look, if you have a data warehouse, so our company, if we come to work with a client, right, and they have a data warehouse, we're thrilled. Right? It's a great place to start, right? But even then, almost inevitably, there's almost immediately something else that they need to cross-reference with that's not in the data warehouse yet, right? And so, like, fine, maybe it's coming into the data warehouse later, but we don't have to be held up by it. Like, we can still connect to it, and no matter how we do it, we can still build a robust production solution that splices in other sources that are maybe even third party, right? And so the mindset we were in for so long, and again, I think the software industry did this to us. Like, this used to be my job, was to inflict this kind of pain, right, on the world, was that we set things up where everything had to be in the same database, the same data warehouse, before you could even get started. And that wasn't necessary. We didn't need to start off that way. So what we talk about is more like a faucets first philosophy, rather than building a ton of plumbing in anticipation of faucets. So the data warehouse is always, or the centralized data stores, they're always there, they're always evolving, they're always getting better. What I'm saying is that waiting for them to reach a certain point has never been a winning game. Your analytics and your reporting need to be out ahead of that at all times. And you can be filling in plumbing behind the scenes. And you'll see that there's still the notion of fact and dimension tables. There's still very much a thing, right, in the Power BI world. And we use a lot of databases to help produce those things. I don't know if I'm helping at all. It's just, it's the monolithic sort of like really, really old school, like we have to get everything in one place before we can get started. That's, I think we can all agree that one's kind of, that principle's done. Sometimes what we found is that, okay, I should repeat the question back. We're having a data warehousing religious fight, is the question. Yeah. That's what we're about to do. Yeah. Like, think about it this way. All of the, boy, I mean, seriously, this will turn into the talk about, heretical thoughts on data warehousing by Rob Collie pretty quickly. Think of it this way, like, the data warehouse's original goal, what does warehouse mean, right? Warehouse means don't lose anything, right? the philosophies that were available to us when SQL transactional tables were like our only storage mechanism for large volumes of data, kind of put us into a bind. It's one of the reasons why I think personally that things like Hadoop and stuff like that have been, you know, these semi-structured stores, these document-oriented stores have become so popular, is because you don't have to think very hard in order to keep things, right? If all you want to do is preserve and not lose, you don't have to think very hard. You just dump stuff in there, right? It's like a garbage disposal. And it's not very expensive either. Now, when it comes time to do some analysis, well, that bill comes due, right? Because you didn't structure anything. Now you have to apply that structure as you at the analysis point. Does that make sense? I was talking about as rectangles. You either store as rectangles, or you have to create them later when you need to extract to perform analysis, right? So you can delay that decision a bit. So many times what we have found is that like slowly changing dimensions, they were necessary for storage. They weren't actually necessary for analysis because people didn't want to be setting an extra filter every single time that they wanted to perform something. We still do that kind of work. It doesn't stop us. I'm not saying that the whole data warehousing, industry and philosophy is invalidated. I'm just saying that you don't need to do that first before you perform analytics. We see all kinds of rearguard actions where after we've produced value for the business, then we can go back and we can start building a more responsible set of plumbing underneath afterwards that's now informed by what we actually need, as opposed to in like a crystal ball anticipatory nature. Yeah?
But how do you relate disjointed, siloed data to each other? Are you going to talk about that? Because you need somehow to be able to relate.
Of course. Yeah, you need keys. Of course you need keys. Yeah, absolutely. Right? And in the example that I'm going to show you, right, like we do this all the time, like with digital marketing. The digital marketing is the data set that I'm going to use. Now it's a fake data set, but still. You've got to be passing keys even operationally from layer to layer to layer, like on your website, if you want to be able to link things up, right? If you don't have keys, you can't just invent them, But it isn't that hard. It's just really, I just don't think it's really that hard. If all you need is an identifier. And this is something I think I benefited from as being a guy that worked in the Excel trenches for so long, is that if you have any way possible to construct a linkage between two data sources, you can get there. And that sort of Excel mindset, I bring that into my data models every day, and it just works.
As an ETL developer, I would say that it's not always that easy, right? You may have customer names stored over here and customer names stored somewhere else, and this is not easy to relate to each other.
No, it's not. No, it's not. But you still don't need to necessarily, you don't have to lead yourself into a gigantic monolithic data warehousing project in order to solve that particular problem, right? Specific problem, specific fix, right? But really, I do have to move us on from this because we could spend 3 hours on this, right? Take the jacket off, we get at it, But yeah, I don't want to make any enemies on that front, right? I just want to show you what the OLAP layer can do that SQL can't do. Did you have a?
I did. So about your slides, so I see how you're talking about siloed. One of the questions I'm having a hard time answering is, once I get my data into a data set in Power BI from all kinds of disparate data sources, how do I get those analytical answers from other systems outside?
How to pump it back out. Yeah. Another hour-long talk we could give is that now that, so the question is, now that I've got a great analysis I built in Power BI, now I need to take those answers and pump them out into other systems. This is what we call good problem to have. It used to be so hard to get good reporting, good analysis, that was the only thing we worried about. But as that becomes less and less of a bottleneck, we start to zoom back and say, oh, this is actually part of a longer end-to-end business process. Holy cow, we actually want to do something with these answers. We want to be able to annotate and add action plans and things we never even got to that before, right? And I think Microsoft is keying in on this. If you see their whole Power Suite strategy, now I'm a pretty keen observer of Microsoft because I know these people. I even know some of the individual humans, right? And I know their tricks, right? And they are absolutely gearing up for exactly this, right? that Power BI and the analysis, we're taking the friction out of that, and we're going to keep taking the friction out of both upstream and downstream. Like data flows, right, is an upstream friction, mostly. All right. I asked for questions, and boy, did I get some. All right. So here we go. Let me tell you about the fake data we're going to use, okay? And then we'll dive in. So we're going to take a digital marketing example. And so we've got users out there, people, not users, human beings, flesh and blood human beings, wandering around out in the world, being exposed to our fake company's advertising, like on Google or Facebook or whatever, right? And sometimes they click on those ads. Sometimes they don't. Right? But when they click on those ads, they find themselves on our homepage. And no, I haven't mocked up a fake homepage to show you. That's as good as it's going to get, okay? And this homepage advertises on it. You can sort of imagine the pictures of 4 products cleverly named A, B, C, and D, okay? And they can click on those pictures and get to the web pages for A, B, C, and D. But again, there's no guarantee, just because they came to the homepage, there's no guarantee that they're going to follow through and look at any of the product pages. They might also look at more than one product page. They might go back to the homepage and click back through. They might look at they might go back and come back. They might look at a particular page more than once even. But very often they might not look at any of them and they just bounce, right? Sad. Now, if they go to one of the pages, then they might decide to buy something. This should look a little familiar because I'm going to put these little blue lines in here. Here are our 3 silos for this story. And so the first silo on the left is a third-party digital marketing platform, right? So like Google AdWords, Facebook Insights, whatever, right? As a little bit of an olive branch from the previous conversation, I will tell you that in our world, when we do exactly this sort of stuff at our company, for our company, we're still landing all 3 of these silos. We're going to land them all in a SQL Azure database as sort of a first starting point. Okay, using any of you use Stitch? It's not a Microsoft thing, but Stitch is amazing. Pull from web cloud source XYZ, dump into Azure SQL Data Warehouse. Amazing product. We just sort of stumbled on it. But that's it. We dump them into that database in their raw form, right? We're not performing ETL on them. We are landing them in a SQL instance. Okay, so that's the first silo. Second silo is the website itself. Maybe we have our own custom, homegrown tracking system and database for our own website. Maybe we use Google Analytics, which, even though it's from Google, it's not the same thing as AdWords data at all. And then, of course, we have our e-commerce system. And all 3 of these have completely separate storage. One of them doesn't even, at least one of them, doesn't even belong to us. OK. That is the stage. And do I need to reshare? Oh, no. What have I done? I ended the slideshow, and now we're... Any clues?
Damn software.
Yeah, seriously. I appreciate that. Display. Well, let's try that. I was using the function keys and the things on my keyboard. Thank you for Windows P. Thank you. That's solid. I use Windows M all the time. I'm a big Windows M guy. But but Windows P, whew, I've learned it's worth the trip. Right there. All right. All right. Appreciate it. Okay. So I'm going to show you, first of all, that I've already loaded this data, as I don't want to bore you with loading data. And so I've got 6 tables here. And if you look at the 3 along the bottom here, left to right, these are the data sources that represent those 3 silos from the previous slide. Okay? So I've got ad display. You could think of this as impressions. This comes from like the digital marketing platform, the Google advertising, that kind of thing. Sessions, that's website sessions. That's our website data. And then the final part of the funnel is transactions. There's all kinds of parallel examples to this. Like you got your CRM system, like potential customers, and then you've got your actual financial systems and things like that. Even our company, managing our business, Power Pivot Pro, we're up to like 6 silos of information, even at our company, that we need to be able to look across in order to get an accurate view of our own business, right? So 3 is easy mode. Now, the data volumes here, I just thought I'd make them interesting because, that always adds something in terms of visceral quality. So ad display. I decided to use 200+ million rows. Okay? This was originally about 7.5 gigabytes of data. And it's a really simple column set. Again, I didn't go and invent a data set that was like end-to-end, super hyper detail complete. There's some thought that went into this for sure. It's not just random. But so on a particular day, this was an ad, how many impressions that it got, how many clicks it got, and how much spend. And it's sort of being done like on a session basis. That's how we end up with so many rows. Lots and lots of potential impressions. And we have different ad IDs. We've only got 6 different ads that we run, okay? Not a big deal, but 200 million rows, again, just to make things interesting. And then the sessions table, I just sort of applied like a factor of 10, roughly, at each level. So there are 200 million potential clicks, essentially, to our, out there, ads dangling in the wind. And about 10% of those resulted in people clicking through to our website. And so we've got, roughly 20 million rows there. And notice that in this case, it is tagged with source ad. And this comes through, in the real world, this comes through on the URL. It's one of the UTM parameters that gets passed through, and it has to be grabbed operationally and persisted. Otherwise, you're just blind, right? You're not going to be able to see anything. And that's actually a lot of work sometimes, even just extracting those UTMs out of like the URLs in Google Analytics. But then there's also, now we're introducing the notion of product page. Did they look at a product page? So this person did not look at product A. It's sorted in a way that sort of obscures the fact that there actually is real data here. I capped it at 3 views per page. 20 million rows. And then again with the factor of 10 going on again, we've got people buying things. And this is about 2 million rows. So again, even here, passing through the transactional system, is the source ad had to be passed through again. Again, this has nothing to do with analytics, but it is real work that has to happen in your operational flow. The product that was purchased, the quantity, the revenue. These 3 columns, of course, are very easy to extract from your transactional system by itself. Okay? And then the other tables, these 3 are just, we call them lookup tables in our world, but yeah, they're dimension tables that sort of span all of this. Okay? Any questions about this? Yeah.
Question on those 0 views.
Yeah.
Does that mean for every impression you've got, every page, and how many views there were?
Yeah, I could have. So what I really should have done in that sessions data set, I think that's when you're talking about the website sessions. I even made a note to myself this morning as I was looking at this. I should have added a column that was like session ID, right? So that you could see that particular session ID, like that human being that clicked through, didn't look at this page and this page, 0, 0, but they did look at this one, for example, right?
So, well, that is my question. So you have, for each session, you have each of the web pages and you show yes or no, or not yes or no, but how many views there were, including zeros.
with the gigantic caveat that this is fake data that I invented. Yes, right, in this particular case, right? Like my friends that I've been working with that are so good at SQL, that work in the digital marketing world, they're running literally tens of thousands of ads per day. So for them, it's very, very easy to generate data volumes like this, and in fact, greater than this. Now, I didn't want to go invent 10,000. I actually named the ads. You'll see that there's some names in them, right? So I just use a small number of ads. So for me, it actually helps me to produce a similar data volume that's realistic to what they use. It helps me to leave the 0 rows in, which I probably would trim out in most cases, right? I was sitting here this morning going like, this crowd is going to call me on that one. I was right. But anyway, you can absolutely arrive at data volumes like this as long as you've got enough different lookup entities, enough dimensional entities like ads, right? Even if they're roll-ups on a daily basis, like aggregates, you still end up with tremendous amounts of data coming into your system in a hurry. Okay? All right, so let's play a game where we say, all right, how hard would this be to do with SQL as our brain, right? Again, with the complete acknowledgement that we got to this point because of SQL, right? Like SQL helped us a lot. The storage layer helped us a lot, right, in getting to this point. It's not, we can ignore it, but we don't use it as our calc engine. So I just started us off here with a simple little report. Just list of all month years. And that's coming out of my dates table, which is one of my dimension tables, okay? And so let's do something easy, right? Let's do the number of impressions, total ad impressions from the ad display table by month and year, okay? And that would be something that you would have, not just you, anyone, would have no trouble at all doing in SQL, right? So I'm going to add a measure, just a formula, to my ad display table. Oh, you know what I should do? I'm going to bring up Task Manager so we can see what all's going on here. Right? We'll flip back. So add display, new measure, add, when the mouse slides down the, all right. So, that's so funny. When the mouse slides away. New, oh boy. All right, we're going to not use the touchscreen mouse. All right, so add impressions equals, it's a very simple sum from the ad display table. Okay. So that's DAX, right? That's a really simple DAX formula, okay? I don't want it part of that report. I want it part of this one, this visual. Okay. This would not be difficult to do, right? It's a pretty simple group by. Yeah, again, I know about those things. It's a pretty simple group by against a single table. 200 million rows. It might have taken a little while. I don't know, depending on your index scheme, right? Don't see a whole lot of things going on here in Taskman. Well, let's also. I'm going to keep falling for that, aren't I? Let's say add clicks, right? Add display, clicks. Okay, so there it is, and all right. So we got clicks, impressions. Again, that's not particularly exciting. How long would that have taken to run though, against a SQL source? Would that have been fast? See, I really legitimately don't know. It depends. All right. Okay. Fair enough. It depends. In this world, it doesn't depend. That's just gonna be that fast. Yeah.
Are you going to show us the Power Query underneath this?
Oh, the Power Query underneath this just loads text files, gigantic text files. If you're really nerdy, I can send you the slide deck that documents how I built the data set. And that, even though it has like no practical real world application, like that's nerdery at its finest. Like I'm just, yeah. The original version of this, never mind, I don't even want to go into it. All right, one more. Let's do click-through percentage, right? Number of impressions as the denominator with clicks as the numerator. It seems like this is no longer failing me. So click-through rate. So we get the lovely divide function. You guys know what the divide function does in DAX? It divides, yeah. It protects against division by zero errors, and it does it at twice the performance efficiency of an if or an if error. Right? Something really funny about DAX is that it evaluates every branch of every conditional no matter what. So divide gets to skip the if trick. This time we should probably set the format on this one, right? Percentage, 1 decimal place, put CTR on there. All right. What about that? Does that make things any harder? Click-through rate? Still staying in one table, right? We gotten any harder for SQL yet? All right. Assuming you had good indexes, right? Yep, totally. I hear that there are ways that it's getting better at guessing what those indexes are. Is that right? Yeah, that's kind of cool. OK, so why do you think my CPU is so low? It's not really in disk and everything, right? It's bored. This is where I was going to introduce a lie, which was that I'm clearly connected to a big server somewhere over the network, right? But no, this is all happening locally on this laptop. So I mean, we're bored. The computer is bored still. All right, was that a question? No. All right. So what about things from another table, though? Let's go to the sessions. Let's create a formula there and say what? Product page views. Sum of sessions views. All right. So now, if I wanted to build this report that groups across, a common variable like month, year, but it's now we're jumping across two different silos, right? Two different silos of data. How would you do that in SQL? I mean, not that you can't, but how would you do it? How would you go about that? There's probably a few different ways to go about it. Subqueries, yeah. And how long would that take you to write? Longer than clicking, yes. Is it minutes? OK. And so you build the report, and then if you have an ongoing conversation with the person that you're talking to that asked for it, what do they do as soon as you give them the report? They say, that's not actually what I needed. It's exactly what I asked for, but it's not what I needed. And this is something about human beings that we need to accept. Human beings do not know this. The number one thing you can take away from the entire session, in my opinion, would be human beings do not know what they need until they have seen what they asked for. Okay? So the whole notion of requirements documents and specifications is really just us lying to ourselves. It'll never happen, folks. You'll never write up a specifications document, execute on it to the letter, and be anywhere close to done, because then you'll immediately discover all of the misconceptions, including on the demand side. Right? So they say, yeah, I need to be able to look at that by ad, right, or by product. This is just all of the product page views, right? So let's look at it by ad. Let's put the name of an ad on there. Okay. See, we have names for our ads. Do you see those? Are those readable from down there? Should we make the font a little bigger? when recently Power BI, it wasn't recently, it was probably about a year ago, they released an improved compression engine that compressed the data even better than it had been. And someone, I think it might have been Chris Webb, said, I didn't think they could get the font size any smaller. That has stuck with me ever since. Okay, so now I can just toggle between performance based on ads. And I'm just bouncing back and forth. And that filter is being applied to both fact tables in that instant that I'm clicking. And again, it might be fun to lie to you and tell you that I'm connected to some server somewhere, but my computer is still just sitting there as bored as it ever was. Like most of the CPU noise you're seeing is background noise. I suppose this spike here might have been that query that I just ran. Yeah?
And that filtering is possible because of the relationships that you're already.
That's right. So the 2 steps of prep that I did with this data model before I came in here was I loaded all the data, and I linked up the relationships, right? And in Power BI and really in analysis services, relationships they're not really quite the same thing as SQL relationships. They're called the same thing, but it doesn't really help you to think of them as the same thing. In my experience teaching people, you should think of them as filter pathways. Their only job is to transmit filters that have been applied to one table over to another table. They don't have any of the other, they do. They have one-to-many semantics. They have all that kind of stuff that you're used to, but they don't do the same things. They're just a filter pathway. Exactly. All right. So, we didn't do spend, right? I hear spend is an important thing, but let's not do that yet, though. Let's do revenue. We like revenue. So we'll go to the third silo, the transactions table. Say revenue. Sum of the transactions table, revenue. Oh, we'll just say revenue dollars. All right. So there's my revenue dollars. And keep in mind, folks, that when I'm saying I've selected the you are getting very sleepy, hypnotic ad, that ad has generated, for this particular month year, it generated this number of clicks, this click-through rate, which is a division of 2 aggregates in itself, right? This number of product page views. Now, we're not breaking it out by product pages yet. We absolutely could. We could put A, B, C, D on here and start subdividing by that as well. And it's generated this number of revenue dollars. If I toggle this to, our stuff sucks less than the competition ad, we get different set of results, and again, the CPU is bored. All right, and other than loading the data, which admittedly takes a little while, it probably was, 20 or 30 minutes, enough to make the demo really boring. But not that long, and it's really kind of a one-time or after-hours process. I started from scratch. There's no other prep work that I've done to make this easy or this fast. And if you notice that I haven't done anything terribly technical, look at my formulas. Right? There's nothing super impressive about me in this situation. It's the software, right? So for those of you that are 100% coming from the SQL world, does this seem like black magic to you? Yeah.
What about the data, the underlying data that's changing constantly? Once you pull that up, how do you handle incremental changes?
Okay, so incremental changes in this world, there's a number of ways to handle them. First of all, a lot of times, incremental changes in source data, like the old philosophy, and it's still adequate in like 90% of the cases, is just to set a refresh frequency on the model in the background. It's like up to 6 or 8 times a day now in Power BI. That's more than adequate for most cases. And seeing how it's Microsoft servers, the Power BI servers that are running our scheduled refreshes for us most of the time, we shouldn't care about the CPU and RAM load that inflicts on them. That's their problem, not ours. So refresh as frequently as you want. So that's one way to do it. Another way, all these are sort of, can be used sometimes interchangeably with each other. There's something called partitioning, which I'm sure you're familiar with the word partitioning, for really, really large data sets where only the most recent stuff tends to be changing. You can configure that it's not refreshing, last year's data every time just to grab the most recent 5 rows, the most recent, 100,000 rows or whatever, right? And there's a third way, which is called real-time data sets, which allows this engine to federate its queries out to to all the different individual source systems. You can also mix and match now. You can have cached imported, like what I've got here, for some sources, and then real-time for others. Now, the performance of those real-time queries isn't going to be nearly as good as what I'm showing you here, because we're still going to be waiting on that individual query for that individual system to process and come back, right? But those are 3 sort of approaches to this.
Sam, I'm a little confused. The architecture is, I have a SQL database.
Yeah.
And you're telling me that has found its way to the Power BI data layer, which is in the cloud?
Yeah.
Finds its way, so that's a lot of hops.
Yes. Okay, so we're talking about data refresh in Power BI sort of in general, right? So the way that they've approached this, Microsoft, is that their cloud servers for Power BI or for like cloud Azure Analysis Services is also an option for the same thing. Both of those need to be at scheduled refresh time. If you're going to set this thing up on a schedule to keep itself up to date, like every night or whatever, right? It needs to be able to get to your data wherever it is, right? Your original SQL sources, absolutely. So sometimes those data sources are, if they're Azure SQL, right, they're not behind your firewall. They're actually really easy to get to those. If anything that's cloud data sources like a layup. For everything else, there's this thing called a gateway, right? Everyone loves the gateway. The gateway is everybody's favorite thing in the world. It's getting easier and easier to configure, but they work. They work just fine. And again, it's not a cost that we need to worry about. I mean, I used to run, like back around 2010, I used to run a cloud data farm that served the same purpose using, we bought Microsoft's off-the-shelf software and was installing it on our own servers in the cloud, right? And running this stuff. And I can tell you that 98% of your hardware need when you're doing that is dictated by your scheduled refreshes, not by the interactive uses, right? And so when you're running scheduled refreshes, that's got to be Microsoft's most expensive cost component on their cloud service, and they're okay with it. So lots of hops, but once it's cached up there in the cloud, it's not a lot of hops anymore, right? If Microsoft is cool with this, I don't think it's really not our problem as the customers. Yeah.
This is all in memory at this point.
It is. It's all in memory. Yeah. It's crazy, isn't it?
It is crazy.
Yeah.
It's the reason why it's so fast.
It is. It's a big reason why it's so fast.
Looking at the CPU and
It's in memory, and it's stored in column stripes rather than row stripes, which is not possible, really feasible at all when you're stored on disk. So it's not just that that RAM has a faster transfer speed than disk. It's just that RAM also has no moving parts, so there's no penalty in breaking a row apart into its column components in terms of storage. And column stores are a cheat code. So column store combined with RAM is just everything that we know, we don't know anymore. It's not even the size of the rectangle of data that dictates the size of the footprint anymore. It's even its shape. Like a tall, narrow rectangle table like this, small number of columns, large number of rows, is going to take less storage footprint in Power BI and in SQL Server Analysis Services Tabular than the exact same size rectangle the other way. That's lots more columns and fewer rows. It's not the acreage, the square footage of the table that matters anymore. And so I'll show you that. So the original data sources for this totaled about 9 gigabytes. 9 gigabytes of text data. And this file, that's how big this file is. And that's roughly what it's, maybe double that is going to be its memory footprint. Now, keep in mind, this is pseudo-random data that I fed it. There's variations in it for sure. but not nearly as much variation as the real world would dictate. Okay? So it's as more variation came into the data, there's less repetition from the real world. You better believe that I'm not going to get 7 gig to 6 meg compression ratio with a real data set. But it'll still be incredibly dramatic, right? Dramatic compression. Again, it's because column stripes, they let you do that. Yeah? Yeah, you can use direct query direct query to connect to a cloud source. I'm assuming so. I haven't done it. Yeah, but I mean, it would be silly if they didn't let you do that. Yeah. Yeah, and you still have to, whatever that direct query source is, you're going to be constrained by, that's going to be the bottleneck in any interactive report that you build. Its execution of its queries is going to be almost certainly on the direct query component. But what I've found is that, like at least 4 times out of 5, when a customer or a client thinks they need direct query, they just haven't realized how good the caching importing default is. And then once they see that, they're just like, oh yeah, you're right, we don't need that. Yeah. Is there a question back there?
Yeah, right now I'm working on a solution where we're trying to transition people off of exporting data out of SRS and onto a tabular queue solution. And the obstacle we're running into is that right now we're having them connect to the tabular queue through a pivot, through an Excel pivot.
Yeah.
And they find that interface difficult to work with and kind of intimidating. And so would you say this is more user-friendly in Power BI and is there a way to...
So the question there was, we have an SSAS tabular model, and when people our users are connecting to it from Excel pivot tables, they are finding that experience intimidating. Yeah, I imagine they are. Yeah, I mean, one of the things I used to own at Microsoft was pivot tables. Yes, we found that people are scared of pivot tables, especially the blank canvas version of pivot tables. All right, how about, if you don't mind, can I just answer that for you, like in the hallway after this? Because that's going to be much more of a human story than a tech story. I want to make sure that there's a couple more magic tricks that I want to get to before we run out of time in here. Yes, sir.
Yeah, I was just gonna say, this makes a lot of sense for kind of exploratory analysis.
Yeah.
Is it really practical for like known value, KPI, standard reporting solutions?
I think it's better at that even. I think that, okay, the question was, I'm going to be because we're recording this, right? The question is, this is great for exploratory reporting, but what about sort of like known value, repetitive stuff, right, that you're just going to be doing every day? Oh my gosh, is this good for that stuff? So good for that stuff. Because again, even those things like KPIs and stuff like that, there's 2 things that you really want with those. Number one, you want to be able to have a very sophisticated calc engine that goes with it, that you don't exhaust people. Like, you want to get those metrics need to be as accurate, as subtle, and as sophisticated to dial out all the noise. And what we've seen over and over again is that when you've got low question velocity, like when you're bottlenecked on SQL as your place to run those calculations, eventually everyone involved just gives up and calls it good enough. Right? Whereas we can get better metrics in this system because we don't get worn out. The other thing is that you still want to be able to explore those. Even those things, those known KPI things, they're just the jumping off point in a world, because like being informed is worthless, right? Being able to improve is the only thing that matters. So how does the action follow out from that? You're like, well, why is that number so bad? Got to drill down, right? Is it bad relative to my peers? Or is the whole business doing the same thing? Or is it just an outlier here? All of those sorts of things. I just don't think there is such a thing as a valuable static report. We've been locked in that mindset because the tools were like that, not because that's what we really needed. That's a great question. Thank you for asking that.
Follow up on that?
Sure.
Doesn't that create some governance challenges though, if like all your KPIs
Yeah.
defined?
Oh, yeah. It definitely creates some governance challenges. But you know what? You already had those problems. They were just out there in the dark in Excel spreadsheets on people's laptops and desktops that you couldn't see. Right? Now they're in a place where you can see them on a server. Right? You have a fighting chance to govern them. Now, it is true, though, that as soon as it crosses that blood-brain barrier into like IT land, now it can be your problem, whereas before, you got to ignore it in a lot of, until it blew up, right? Then it's still, right? But there is an issue there, right? That like sometimes ignorance is bliss. But as a total business picture, if you view the business as opposed to the individual components of the business, from a total business, the problem has not gotten worse. The problem has only gotten better, right? When you can implement those KPIs in a language like this, rather than SQL, rather than Excel. All right, let me show you the sort of the two last metrics that I wanted you to see. So we have revenue dollars, right? So, January 2017, we made, $777K from this particular ad, from, ultimately downstream. People who clicked that ad, came to our website, and eventually made it into the funnel, and at the bottom of the funnel, and bought something to the tune of $777K, right? Well, how much did we spend to get that, right? We had to spend on those ads, right? So we go to Ad Display, New Measure, Ad Spend equals, just another sum of Ad Display, Spend. Okay. All right, so we'll put spend on here. And now I'm going to show you, please. That's the column. So there's the column, and I could drag the column onto the report and set its default aggregation to sum, and I would get the same number. However, that would be bad data modeling hygiene, because what we want is a bunch of fundamental measures for every column, maybe multiple different, you could have multiple aggregations for the same column, and then reference those measures in other measure expressions, rather than constantly going back to writing the sum of the column over and over again. You don't get good, reusability and maintainability in that way. Difference between what I call explicit versus implicit measures. We always want our measures to be explicitly written, even if it seems silly at that first step. Okay, so we don't talk about margin typically in digital marketing for ad spend relative to revenue dollars. We expect more from our digital marketing. We expect free lunch. So does anyone know about the acronym ROAS? Anyone ever heard of ROAS? No? ROAS, return on ad spend. And it's a ratio. Revenue dollars, we could use the divide function, right? Let's be good. Divide revenue dollars by ad spend. Oh, my friends that run a digital marketing empire out of San Diego, if you hang out with them for a day, you're just going to be hearing ROAS, ROAS, ROAS. Now, a ROAS of 30 is insane. They like their ROAS in like that 1.5 range. And it's really kind of interesting. It has nothing to do with this talk, but it's still interesting enough to mention. Like, if our ROAS is too high, that means we actually weren't spending aggressively enough. We could have squeezed more, in terms of optimization, we could have squeezed more out of the world if we'd been running more ads and pocketing. So they actually don't want their ROAS too high. They want it Goldilocks. They want it just right. It's kind of interesting, right? But we don't talk about margin, we talk about ratio. Right? That's why the world has gone digital. It's because you can get a ratio of return. It's insane. So this is why newspapers are going under, for instance. Okay, so ROAS, right? So think about that. That calculation alone is a ratio of sums from two different fact tables, one of which is a 200 million row fact table, one of which is a like 700,000 row fact table or 200,000 row fact table. What about, let's take a couple of things off of here, like just to give us some more space. Okay, what about ROAS previous year? So our first actually sophisticated calc date add, dates, date, -1 year. Nothing up my sleeve. Would that have been fun? So this now matches with this, for example. Just randomly shifting by a year in time. Does that work at just the month level? No. If I throw date on here, individual date, and drill down, I never know what to do here. I hate this thing sometimes. Just date. There we go. All right. So if I go down to just individual days, it still will give me, it works at every level of detail. I was at the month level before. I didn't have to rewrite the formula or do any additional work to get it to work at other date granularities. So drill up. But that would have been fun, right? In SQL, what I just did. And then we could obviously do something like ROAS change versus previous. Divide. So ROAS minus ROAS previous divided by ROAS previous. So that should be a percentage. 1 decimal place. Let's put that on there. Do you like that one? That's the one that I'm told, even though the things would have been difficult in SQL, I'm told that one was really kind of not easy in SQL. And keep in mind that I'm still over here, I'm still slicing by different ad campaigns. And that's all it takes. That's a total, there's some caching that happens, but like you can't even tell the difference because the first time I clicked it, it didn't make any, you still didn't notice it, right? It still recalculated so quickly that it's free. This tool allows us to both explore and build at about the same speed that we think. Even though the data, we didn't necessarily have to land the data in one unified, storage layer to begin with. We don't need to bring it together at that level. Yeah? So the question is, there was actually a couple of questions mixed together, like for a given business, or even like a given, like, I don't know, like department or division of a business. Right. I work in a university, so we have a lot of disparate things going on. Yeah, of course, yeah. And there are several centralized databases. We're going to have to, bring in all of those databases, mash them together. Sometimes it makes sense to put them in one kind of a mashup, and sometimes it doesn't. Yeah. So how do you manage that environment to provide it so that everyone can get it in a simplified manner? Am I using 7 different AD groups for people to access different parts of the model? Yeah, yeah. What is your recommendation? Well, so in terms of like when to create different data models for different purposes, or when to try to bring them all together into one overall data model. Let's take that as the question for the moment, right? If there were a simple enough answer that I could give you to that, you'd already know the answer, right? You'd just looked it up. Google would have told you, you know? The answer is always, well, it depends, right? And our past experience and wisdom can help drive us in those cases, but we still need to know what those cases are. So when I teach classes on this stuff, and people ask me that question, they're just like, they're not veterans of the trenches like you are at this point. They're just someone sitting in a class really excited and bright-eyed about this is going to be great, right? They haven't gone out and discovered those sorts of problems yet. Still good problems to have. But I tell them, well, first of all, start with the fact tables. Right? If you've got two models that use basically the same fact tables, that starts to smell like something that maybe should be unified rather than split, right? Especially if they start to use the same sorts of like fundamental metrics in them. It's a fuzzy logic algorithm that sort of tells you when to. Now, I'll give you another example from the real world, which I can talk about, you know, my own company's data models, because it's not giving away any secrets that I care about. We have a full like cash flow forecast model that starts from CRM, you know, Salesforce, and probabilities of closings and probabilities of what dates those services would be delivered. So it starts way upstream in CRM with business that hasn't even been closed yet. It takes into account our financials, like, you know, what's our AR look like, accounts receivable, what are we owed, right? It takes into account what services are being delivered right now. That's coming out of our time tracking harvest software. We have another system that's our trainer assignment system. So it's like we know who's going where and when. Like all of those things need to come together to give us a picture of our revenue. Like what it's going to look like 2 months from now, what our cash flow is going to look like 2 months from now. Okay. Separately, we've been running digital marketing, right? A similar thing like I've been showing here, not nearly at this scale. You know, we don't have 200 million rows of data, but well, guess what? We started that as a brand new model, just for simplicity's sake. Right? It was just so much noise, so many moving parts. Now, in reality, it should be upstream even further from our CRM, right? Long term, I expect that model to be kind of merged into this other one because it is, you know, like it takes people, they see your ad, they come to your website, they visit, they don't buy immediately, they think about it, you know? So that how active people have been on your website and how effective the ads have been is the next horizon. So those two models at our company have been sort of on a collision course with each other for about 8-9 months now. We know it's coming, but there's still so many moving, you know, things that we're adjusting. You know, we're even operationally as a company, we're changing a lot still. So like we're not in any particular hurry, but I would say that, you know, this time next year, we will no longer have a separate digital marketing model. We will now have the end-to-end, you know, monster model. Yeah, I mean, but again, I wouldn't overdo it, right? Like the one data model, like if you've got, for example, it doesn't make any sense to build a data model that's got like 2 archipelagos of tables that are related to each other, but not touching each other at all in the relationship diagram. That's just putting 2 things in one model for the sake of it. You know? I would never do that. Because you would never, in a given report, you would never use items from both archipelagos, right? Maybe you would. That might be a reason to do it. And, but I wouldn't put things together just to do it. But yeah, I mean, the less you've got, the better. Of course, at the same time, even if you get to 1, there's still going to be some things going on that are fringish, you know, like sort of experimental around the margins. There's going to be new models popping up all the time that might live for 2 months and go away. They might, you need to prune them over time. They might eventually need to move upstream and become sort of enterprise governed. Who knows, right? But yeah, you're always trying, I think, there should always be sort of like this bubble of dark matter pressure that's trying to push the galaxy back in kind of lightly.
So are you
Yeah, I mean, we're still waiting for really good source control. Really good source control on these models. When that comes, that will be, we will all, you will hear us all screaming. I mean, seriously, like, most of the time, you really want a model developer, right? Like, today, that's the way you do it. Like, and if someone else needs to make a change, what they need to go to that person and say, hey, it's almost like manual checkout, like verbal checkout. Like, and that's another reason that sometimes, like, honestly, that's one reason, a big reason right now why our digital marketing model is separate, is because we've got, one architect for this one and one architect for this one, and we'd be constantly clobbering each other. They need to settle down and stop evolving before we really even realistically consider, merging them.